question. First question, calculate the speed of an object on the equator due to the rotation of the Earth. Given that the radius of the Earth is 6.38 times 10 to the power 6 meter. So now if we wish to calculate the speed, so where's my pen? Red color. Okay, so first question one, the speed V is equal to 1 revolution of the Earth is equal to 2 pi r over the period. So this means that it will be equal to how much? 2 pi times with the r radius of the Earth is equal to 6.38 times 10 to the power 6 meter over the period. What is the period? Period will be equal to one revolution is 24 hours. 1 hour with 60 minutes, every minute with 60 seconds. So at the end, we get that it's around 464 ms negative 1. Okay, question number 2. Even though an object on the equator performs circular motion around the center of the Earth, but it's not a satellite of the Earth's friend. Now, we notice that they said that even though an object on the equator performs a circular motion around the center of the Earth, it is not a satellite of the Earth. Why? That is because not all the gravitational forces is provided as the centripetal force. Okay, so that's because some of the energy is used to it's become the gravitational potential energy. If kinetic energy never vary, because mv squared over r that is come from the centripetal force. If an object can move orbiting the Earth in the circular motion, there will be an Fc. Fc is equal to the mg. But now the object with a certain height again. So this means some of the energy will lost and so on. Okay. So question number 3. Question number 3. Calculate the period of the satellite orbiting about an orbit close to the surface of the Earth. This means that, let's say, on the surface of the Earth, you see, radius of the Earth is almost near to 6.3x times 10 to the power 6. We consider actually it's on the surface of the Earth. So we use the concept Fc equal to the Fg, gravitational force. So this means that it will be mv squared over r equal to g m e m over r squared. Let's say this is the distance on the surface of the Earth, re. This will be re squared. Okay, so from here we get that v squared will be equal to mgmem over r squared. It will be g over v squared will be equal to g r e squared over r. So as a result, we get that it will be equal to g r. So v squared will be equal to g r. Okay, so from here, let's say, you see, m and m cancel. G, where the g is equal to g m e over g m e over this one re. Okay, g m e over r squared. this will be the G. Okay, so from here, GR square we get that V square is equal to GR. So from here, what we can get, the T. T will be equal to 2 pi R over the V over the square root of GR. That means that this V is equal to square root of GR speed. So at the end, we get that this T will be equal to how much? This T equal to 2 pi with square root of R over G. So put all the information into the formula. So we get that we have 6. This one 2 pi R will be the radius of the earth. So that means I write here, yeah. So it will be equal to 2 pi square root of 6.38 times 10 to the power 6 over 9.81. So we get that the period is around 507 seconds. Okay, get it? Okay, next question, question number 4. Calculate the distance of the geosynchronous satellite. That means geostationary satellite from the Earth's surface. So let's go through the what's found. Okay, for question number 4. Where's my pen? For question number 4, we still use that Fc centripetal force equal to the gravitational force. So this means M that means that mv square over R is equal to G M E M over R squared, the distance. Okay, so from here, given that T is equal to 2 pi R over V, that means V is equal to S over T, right? So that means that the speed will be equal to 1 revolution, that is 2 pi R circumference over T, right? So T is equal to 2 pi R over V. Here comes the formula how to get the period. Okay, so now, okay, what we get that it will be equal to 2 pi R the V. From here, we can get that the V, okay, let's say this is the equation 1, this is the equation 2. From equation 1, okay, what is the V? V square is equal to G M E M over R squared divided by M divided by R. Okay, so V square will be equal to G ME, cancel, cancel. So this cancel with R, ME over R. Okay, so that means that from the calculation, we get that the V is equal to square root of G ME over R. Okay, so this is the equation 3. Replace the equation 3, substitute equation 3 into equation 2. So we get that T is equal to 2 pi R over the V. V is equal to G ME over R square root. So we get that to solve the problems, I use both sides as square root. So that means that T2 is equal to 2 pi R square, right? That means that it will be 4 pi R square over G ME over R. Okay, so resolve it. That means T2 is equal to 4 pi R square R3, the power 3 over G ME. So use the formula, substitute everything in. Period, 1 day is equal to 24 hours times with, okay, 3600 seconds. So 1 hour with 3,600 seconds. So this is the period. This is the time for 1 revolution, the period. So period square is equal to 4 pi R. R, what is the R? We don't know what is the distance. That's R3 over G GME. They give us the GME or not? Let me see. Okay, so GME, we can use that. Okay, we use the G is 6.67 times 10 the power 6.67 times 10 the power -11 times with the mass of the Earth. What is the mass of the Earth? Let me see. Given that the mass of the Earth will be equal to 6 times 10 the power 24. So it will be equal to how much? So find out the R at the end. R equal to how much? Okay, ladies and gentlemen, this one, we get that it will be around 4.23 times 10 the power 7 meter, the R. We also can use alternative method. Okay, so what is the alternative method we use? For example, as we know that G is equal to G ME over R square, right? Okay, so this means that from here, the formula of GME is equal to GR squared, correct or not? So from the formula just now, T squared equal to 4 pi R cubed. T squared equal to 4 pi R cubed over how much? Over GME, over the GME. So if GME equal to GR squared, we substitute into the formula. We get that it will be T squared equal to 4 pi R cubed over GME will be equal to GR squared. Okay. Okay. This method is much easier. So T squared will equal to 4 pi R3, R2, that's mean 4 pi R over G. Okay. So that means same thing. 1 day, 24 hours with 3600 seconds. So square root, sorry, the power 2 square is equal to 4 pi divided by 9.81 times with R. Okay, times with the distance of R. Okay, so let me see. GR. Okay, cannot plus. This should be like that. This is G, radius of the Earth. This must be the RE squared. Okay, so this is RE squared. Okay, if RE squared, that means that this one we need to remain as R3 and RE squared. So 4 pi R cubed 9.81 times with RE is 6.38 times 10 the power 6 the power 2. So at the end, we still get the R equal to 3.6 times 10 the power 7 meter. So this is the alternative method to get the answer. Okay. For next question, question number 5. Okay, normally mass of the earth were given. Okay, Kasavatini, the mass of the earth normally were given in the question. Don't worry, during the exam, yeah? Okay, so now, next, you are welcome. Okay, let's go back to the question number 5. Question number 5, if the field of vision of a satellite station on the earth is 60 degrees and the satellite is to be in the field of vision for 6 hours per day. So what is the angular velocity of the satellite? 1, what is the angle of the velocity of the satellite? And 2, hence calculate the distance of the satellite from the earth. That means that when it moves for 60 degrees in circular motion, the time taken is in 6 hours. Okay, so I think, okay, the time just left 2 minutes. So 2 minutes, I don't want to continue with this question. Okay, we need more than that. Okay, the time, that's period to solve it. So I stop here for today's lesson and we continue again tomorrow. So I want you all try to solve the question number 5, number 6, number 7, number 8, number 9, and number 10. And we discuss again on next lesson. So that's all for today's lesson. So student, any question? If no question, we stop here and thank you very much. See you tomorrow.
Thank you, sir.
You're welcome. See you.
Thank you, sir.
Okay,
Thank you,
bye.
sir.
See you.
Thank you,
Thank
teacher.
you, teacher.
You're welcome.
Thank you, teacher.
Okay, bye. See you. Khalid, Eric, Jess.